Hello everyone, and welcome to our in-depth guide to Python's built-in data types. If you are learning Python or looking to solidify your coding skills, understanding data types is like learning the alphabet of programming. It's the foundation for everything you will build. In this video, we are going to explore Python's most important data types, from numbers to sets with practical examples and real-world applications. We will also share the best practices to help you write clean and efficient code. Grab a notebook, fire up your Python editor, and let's get started on this data type journey. So, what exactly data types are? Think of them as the building blocks that define what kind of information a variable can hold and what you can do with it. For example, a number like your bank balance is different from a text message you send to a friend, and Python needs to know how to handle each one. Python's data types are incredibly versatile and fall into several categories: numeric types for calculations, text for words and sentences, Booleans for true or false decisions, sequences like lists and tuples for ordered data, mappings like dictionaries for key value pairs, sets for unique collections, and even a special type called none for when there is no value at all. Each type comes with its own superpowers, and by the end of this video, you will know how to wield them in real-world projects. So, let's kick things off with numeric data types, which are essential for any kind of calculation. Python offers three numeric types: integers for whole numbers, floats for decimals, and complex numbers for advanced math involving imaginary parts. Imagine you are running an online store. Integers could represent the number of items in stock, like 50 t-shirts. Floats might be used for prices or for calculating shipping weights, like 2.5 pounds. Complex numbers are less common but might come up if you are working on scientific simulations like modeling electrical circuits. Let's see this in action with a real-life example of calculating a shopping cart total. Let's say we have items in stock is equal to 50. It's an integer and number of t-shirts, and price per item is equal to 90.99. So it's a float, price in dollars. So price in dollars, yes, say price per item. And now let's say discount is equal to 0.1. It's also float. 10% discount, and complex calc is equal to 3 plus 4g. So complex for advanced math. You can use all of them separately in different fields and for different purposes. But first, we will perform an operation. So it's an example for calculating a shopping cart total. So I will try it. Let's say cart total is equal to items items in stock multiplied by price per item. Let's say we multiply it by 1 minus discount. And let's print it like a formatted string. We will also see them in input and output. and close the bracket. And card total is that. And let's say prints, we use type, we use type to print type of an item. So inside parentheses, you can write items in stock. Items in stock, yeah. And after that, let's try type price per item. And then print type complex calc. So if I print them, it will give $899.55 and 55 cents and $899. So the types of variables are integer, float, and complex respectively, as we talked about it before. In this example, we used integers and floats to calculate a discounted cart total, which is something you will see in e-commerce platforms like Shopify or Amazon. The type function helps us to confirm what kind of data we are working with, which is super useful when debugging. Numeric types are the backbone of financial apps, data analysis tools, and even games where you need to track scores or coordinates. Next up is the string data type, which handles text, think names, addresses, or even the content of a tweet. Strings are defined using single or double quotes, and they are incredibly flexible. In real life, strings are everywhere. If you are building a customer management system for a small business, you might store customer names or email addresses as strings. Or if you are creating a chatbot, strings are what you use to craft responses. Strings also support operations like concatenation to combine text, repetition to repeat phrases, and slicing to extract specific parts. Let's look at an example where we are generating a personalized greeting message for a customer. Let's say our customer name is, so our customer name is Alice Smith, and our greeting message is welcome to our store. Our greeting message is welcome to our store. So if I want to concatenate these two and craft a message, I will write message is equal to dear a plus it performs concatenation. We will see in the upcoming videos. Don't worry on that. I will handle this in each video related with it. So dear customer name and maybe a comma, and we can write in lowercase and concatenate with it. Greeting, and this might be too much and I can break the line. Greeting message. That's right. So I break the statement into two parts using this backslash because it will be too long if I put continue. So, but okay. Now let's print it. Let's print it and see what happens. Okay, let's leave a space here and run it again. Okay, dear Ally Smith, welcome to our store. Maybe you can fix things like this spaces. You can set according to your own customized model. You can set it your own. You can specify the number of spaces, etc., and no problems there. And so it printed out this one. Here we use strings to create a customized greeting message, which is something businesses do all the time through platforms.
Slicing lets us just to grab a few words or letters, and repetition lets us repeat a word or letter.
Sorry, print message 1 to 4. And you can see it writes here. Now let's repeat it, repeat it 2 times. Just multiply it by 2. The string for the strings, it will just repeat the string. For numeric data types, it will multiply it by 2. Here. So it has been repeated 2 times. If you write 10 times, it will get repeated 10 times. Strings are your go-to for anything involving text, from web scraping to formatting user inputs in a form. So you will use it frequently, and it's an important data type for us. Now, let's talk about Booleans, which are all about true or false decisions. Booleans are like the traffic lights of programming. They tell your code whether to go or stop. In the real world, Booleans are used to control logic. For instance, if you are building a login system for a website, a boolean might indicate whether a user's credentials are valid. Or in a smart home app, a boolean could track whether a light is on or off. Booleans are simple but critical for decision making in code. Let's see how they work in a user authentication scenario. So let's say there is a variable named authenticated equal to true and is admin false. So you start with an uppercase, and let's try if. We will also see if else blocks, but I'm just showing you an example. Print if is authenticated. Print access granted. Else print access denied. And let's say if is admin, print print admin controls unlocked. Else standard 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 user access only. So in real life, you will change all of this with real actions, but it's just a simulation. So it's authenticated true, but the person is not an admin. What will it do? Okay, it says access granted and standard user access only. So if it was an admin, if it was an administrator, let's run it again, as it says access granted and admin control unlocked. And in this example, we used Booleans to simulate a login system, something you would find in apps like Gmail or Netflix. The isAuthenticated boolean decides whether the user gets in, and isAdmin controls access to special features. Booleans are also great for toggling settings, like enabling dark mode or checking if a subscription is active. Moving on to sequence data types, which are all about ordered collections, Python gives us lists, tuples, and ranges, each with unique strengths. Lists are mutable, meaning you can change their contents, making them perfect for dynamic data like a to-do list app. So let's write lists mutable. Second, tuples. Tuples are immutable, so they are ideal for fixed data like GPS coordinates that shouldn't change. So let's write tuples and say immutable. Third one is ranges. Ranges are great for generating numbers in loops, like iterating through page of search results. Let's explore this with a real-world example. Before this, range generating something. So let's start by lists. So let's write grocery list, grocery underscore list equal to apples, bananas, bananas, and milk. If you want to append a new element to this list, you can simply write grocery list dot append bread. And if you want to change an item on this list, you can just access the related item by using brackets. So square brackets will be helpful. So if you write grocery list for index 0 and assign it to a different value like orange, the apples will become orange. For lists, it's like that. They are like arrays in other programming languages. We will also talk in detail about lists in another video. But for now, just know that you can change items by accessing like this. It starts from 0, so apples is the 0, and bananas is the first one, and milk is the second one. So you can access by writing, you can access bananas by writing 1 there, and if you write 2, you will access milk. So let's change it back to 0, and let's print it. It says orange, so it has been changed. Bananas, milk, and bread. So it's successful. Now explore tuples. As we said before, tuples are immutable. So let's say store location is, you can define lists by using square brackets and tuples by using normal parentheses. So 40 points. Okay, and let's write something randomly. Okay, and we print it. We print it. Store at that location. So it writes store at blah blah blah. And if you want to change it, let's try to change it. Store location. So let's write this says 30, comma 40. So it's valid. is valid for tuples to define a value. But if you want to change it like this, so store location, tuple object does not support item assignment, so cannot do something like this. So let's say, and now, let's explore ranges. Ranges are for generating something like numbers, etc., and we can loop through them. So let's craft a range and let's write print islands to visit. And for islands in range 1 to 4, 1 to 4, let's see, print f. I think there's like a list of islands or etc. Um, islands 1, or you can just write island. So island 1, island 2, and island 3. So it prints from 1 to 3, but 4 is not included. So be careful at that. The end of the range is not included there. In this example, the list lets users add or update items, which is exactly how apps like Instacart work. The tuple ensures the store's coordinates stay fixed, which is critical for navigation features. The range helps us loop through islands, similar to how you might display a sequence of options in a menu. Use lists for flexibility, tuples for reliability, and range for iteration. So let's talk about mapping types. Mapping types, or also called as dictionaries, are Python's way of storing key-value pairs, and they are a game changer for organizing data. Think of a dictionary as a digital address book, where each name is linked to contact details. And think this name as the key and the details as the value. Dictionaries are mutable, so you can update them and they are perfect for quick lookups. In real life, dictionaries are used everywhere, storing user profiles in a social media, tracking inventory in a warehouse, or even managing settings in a game. Let's see how a dictionary can manage a student's profile in an online learning platform. So let's start coding. Let's write student, or start from there. Student is equal to brackets, open bracket and close bracket. And let's write name is equal to John Doe. And age is equal to 20. Courses equal to a list which holds Python and data science values. Is enrolled is enrolled is a Boolean variable that is equal to true. Okay, and don't forget comma here. And you can define them, you can assign them using colons. So our student is defined here. So let's print student. Let's print student. It prints the full variable. So let's print its his or her name, or what you call. Let's print his name. That's right. Student name. And you should do it in double quotes. We'll write the case name in double quotes inside square brackets. So let's print it. John Doe. It says John Doe. So let's get his age by writing student square brackets and inside double quotes age. So I can get his age. Age is 20. Okay. And all other things like courses is enrolled, everything I can get from here. So this dictionary tracks a student's details, similar to how platforms like Coursera store user data or maybe Udemy. We can access values by their keys, update existing ones, or add new ones, making dictionaries incredibly dynamic. They are your go-to for structured data in projects like APIs or databases. Now let's talk about sets. Sets are all about uniqueness. They are unordered collections that automatically remove duplicates, making them perfect for tasks like finding unique visitors to a website or filtering duplicate entries in a dataset. Python has two set types, regular sets, which are mutable, and frozen sets, which are immutable for when you need fixed corrections. In a real-world scenario, imagine you are analyzing customer purchases to find unique products sold. Let's see how sets can help. And let's write purchases equal to brackets, brackets, and write laptop, laptop, phone, tablet, and laptop again. And let's print. Do not do not get confused. It's not a dictionary since we have not used key-value pairs and we only used curly braces. Inside them are values separated by commas. So we have defined a set. So write percentages and it will print laptop, phone, and tablet. But there's another laptop here, so it did not print duplicate value. So it's great. So if you want to add new product, you can simply proceed by using add function of set. We will see functions of most of the data structures we frequently use in the next videos, but let's see add. Let's add headphones. Let's add headphones and print first again. Okay, headphones is added. Now let's try frozen sets. So let's write categories equal to frozen set, and can define it inside parentheses and brackets again. And let's write electronics, clothing, books. Print categories. As you can see, it printed out electronics, books, and clothing. So Let's try to add something to it. Let's try to add something to it and write categories. That yeah, there's no such function. Yes, what are the functions? Copy difference, intersection is joined, and something like this. Cannot add any new elements. So it provides a completely frozen set, and so you cannot change or modify or update it under any condition. Here, the set ensured we only kept unique products, which is useful for generating reports in e-commerce systems like eBay. The frozen set could represent fixed categories that shouldn't change, like in a product catalog. Sets are also great for mathematical operations like finding common items between two customer orders. Another unique data type in Python is none type. The none type is Python's way of saying nothing here. It represents the absence of a value, similar to null in other languages. In real life, none is used when a variable hasn't been assigned a meaningful value yet or when a function does not return anything. For example, in a weather app, if the API fails to fetch data and does not show you the weather conditions, you might set the temperature to none to indicate missing information. Let's see none in a simple data fetching scenario. And let's write weather data equal to none. If weather data is none, you can just check it by using is none for if condition. Is none print failed. Else you can print temperature if it exists. So let's run it and see it prints failed. So it means you could not fetch data. Your app is failed in this case. None acts as a placeholder, letting our program handle missing data gracefully, which is critical in apps that rely on external APIs, like weather or stock market trackers. It's a small but essential tool for robust coding. Before we wrap up, let's talk best practice to make your code robust and efficient. So, first, always choose the right data type for the task. Use lists for collections that might change, playlists, like playlists in a music app, or you could maybe use something like to-do lists, like playlist, to-do list, etc. This might vary depending on your needs. Or you can use tuples for fixed data like days of the week. And second, avoid mixing types in collections unless it's intentional. Keeping a list of all numbers or all strings makes your code predictable and easier to debug. Finally, validate data before converting types. For example, if you are converting user input to a number, check that it's numeric first to avoid errors. These habits will save you headaches. Whether you are building a personal project or working on a team's code base. If you found this video helpful, give it a thumbs up, subscribe for more coding tutorials, and hit the bell so you never miss an update. Thanks for watching.